Good evening, boys and girls. Good evening. Give me the clearance. Saksham Tech and Games. Tech and Games have meaningful name, beta. Tech and Games का मतलब क्या है? अच्छा नाम रखिए अपना. बोलिए, what is the question? Tech and Games. ओहो, कौन सा क्वेश्चन आया था भाई? बताइए हमें भी, यहाँ पे हम डिस्कस करेंगे. Tech and Games, please tell me on what topic the question has come in today's NIC exam. 32 KB वन RAM chip और 2048 KB. वेरी गुड, वेरी गुड, वेरी गुड. तो आपने जरूर कर लिया होगा क्वेश्चन. Similar question we worked out, is it not? Yes. Excellent. ठीक है, वेरी गुड. चलिए मुझे सबसे पहले क्लियरेंस दीजिए. इज एवरीथिंग क्लियर? ऑडियो वीडियो क्लियर है? तो हम स्टार्ट करेंगे क्लास. पर्टिकुलरली ऑडियो क्लियर है क्योंकि आज मैं नया माइक यूज कर रहा हूं. तो यू हैव टू टेल मी हाउ इज द ऑडियो क्वालिटी. इज इट ओके? वेरी गुड, वेरी गुड. एक्सेलेंट. टेक एंड गेम्स. ऑडिबल, ठीक है. तो चलिए बच्चों स्टार्ट करेंगे. वेरी गुड इवनिंग टू ऑल ऑफ यू. वेलकम टू PW प्लेटफॉर्म गेट वाला सेगमेंट एंड दिस इज डॉक्टर खलील खान वेलकमिंग यू ऑन बोर्ड टू फास्ट ट्रैक कोर्स ऑपरेटिंग सिस्टम. और आज हमारा डिस्कशन होगा बच्चों ऑन द टॉपिक ऑफ फाइल सिस्टम. लेकिन फाइल सिस्टम पे जाने से पहले वर्चुअल मेमोरी के कुछ बेसिक टॉपिक्स है, उसे कवर अप कर लेंगे एंड देन वी विल स्टार्ट विथ फाइल सिस्टम. ठीक है. तो फर्स्ट ऑफ ऑल फ्यू क्वेश्चंस विल वर्क आउट. ठीक है, विल वर्क आउट ए फ्यू प्रॉब्लम्स एंड देन विल गो अहेड विथ. देखिएगा ये पहला क्वेश्चन है. मैं चाहूंगा कि आप इसे वर्कआउट करो पहले. Yes, Porus Prajapati. Good evening. I would like everybody to work out this problem, please. मेरे साथ प्रैक्टिस कीजिएगा प्रॉब्लम जैसा कल NIC में आया. हो सकता है गेट में भी कुछ ऐसे वैरायटी के क्वेश्चन जो हम वर्कआउट कर रहे हैं, ऐसे कुछ क्वेश्चंस आए नेक्स्ट गेट में भी. सो प्लीज डू इट. रीड दिस क्वेश्चन and try to tell me what is the answer for FIFO first and then LRU. हाँ बोलिए. टेक एंड गेम. व्हाट वाज अदर क्वेश्चन? बोलिए, क्वेश्चन बताइए मुझे, हम डिस्कस करेंगे. क्वेश्चन बताइए. टेक एंड गेम्स. Induced pit faults. Artificially induced pit faults, I don't know what is that concept. I have to see the whole question. मतलब ऐसा ऐसा अगर समझे तो हम 75 एक्सपेक्ट कर रहे हैं आंसर अनडिटेक्टेड. चलिए ये इसका आंसर बता दीजिए सबसे पहले एवरीबॉडी. हाउ मेनी पेटफॉल विल हैपन विथ FIFO रिप्लेसमेंट. अब देखिएगा virtual memory system has an address space of 8 kilowords, memory space of 4 kilowords, okay? And a page and block size of 1K words. The following page reference changes occur during given interval, okay? Determine the 4 pages that are resident in memory after each reference change if the replacement algorithm used is FIFO. चलिए सबसे पहले FIFO से वर्कआउट करना पड़ेगा. I hope you are doing. So we have to work out with 4 frames. Initially, all frames are assumed to be empty. Arjun Reddy, good evening. Initially, all frames are assumed to be empty. This is a reference string, exactly reference string for 8 pages. So, सबसे पहले we are going to refer page number 4. So that will cause a fault. So page number 4 will cause a fault. Page number 2 will cause a fault. 0 will cause a fault, no replacement so far. 1 will cause a fault, no replacement so far. फिर उसके बाद देखिएगा 2. So first in first out page will mark it here 4. Then 2 will not cause a fault, 6 will cause a fault, will be replaced by 4. So 6, this first replacement. So resident pages are 6201. So 2 is the first in first out page. Next 1 will not cause a fault. 4 will cause a fault. Will be replaced by 2. 4, 6, 0, 1. Then 0 is the most in FIFO page. फिर उसके बाद देखिए 0, 1 will not cause, 0 will not cause, 2 will cause a fault, will be replaced by 0. So pages resident in memory are like this. And then eventually 1 is the first in first out page here. 3 will cause a fault, so replacing 1, 3, 2, 4, 6. Now among this 6 is the first one, first in first out page. So 5 will cause a fault, replacing 6. So 5, 4, 2, 3. 4 is the next victim. So 7 will cause a fault. So we'll be replacing 4. So 7, 5, 2, 3. ये है working of first in first out. उसी तरह you can work out for least recently used. Okay, like that you can work out for least recently used. Right. So number of page fault you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 page fault for FIFO. Can you work out and tell me in a similar fashion for LRU, least recently used? Least recently used, how many page faults will occur? Please work out and let me know. So Niket Singh is saying 11 page fault with LRU. Okay. Other people also please respond. 11 page fault. Niket Singh is saying 11 with LRU. Others also please confirm. Is it right? Because I am not doing it here. आपको पता है आप कैसे कर सकते हो. Saurav Kumar, what is the use of above data? देखिए 8 pages है. Those 8 pages are referred in this pattern. 4 kilowords मतलब there are 4 frames because block size, that is page size is 1K words. In a page memory, the page hit ratio is 0.35. The time required to access a page in secondary memory is equal to 100 nanosecond. डायरेक्ट क्वेश्चन है खान, डायरेक्ट प्रॉब्लम है जो हमने यहाँ पे पिछले क्लास में भी किया था वर्चुअल मेमोरी में. सेम क्वेश्चन है, एक्सेप्ट दैट डेटा इज डिफरेंट. P इंटू एस प्लस 1 माइनस पी इंटू एम, यही इक्वेशन आपको यूज करके सॉल्व करना है. जो प्रॉब्लम हमने लास्ट क्लास में डिस्कस किए थे वही क्वेश्चन है. चलिए बच्चों, ये क्वेश्चन वर्कआउट हो चुका है. ठीक है. आई मीन व्हाट इज आंसर यू आर गेटिंग मिस्टर खान? Mr. Khan, what is the answer you are getting? So it will be like page hit ratio 0.35 into 100 nanosecond plus 0.65 into 10 nanoseconds. That's it. Whatever is the value, you have to select it. How much is it coming? You can check out that. 0.35 into 100 nanoseconds. So that becomes 35 plus 0.65 into 10, 6.5. So Saurav Kumar is saying 11 only. Okay, we'll go with 11 LRU, no problem. ठीक है बच्चों, अब नेक्स्ट क्वेश्चन पे जाएंगे. देखिएगा, ये इज अ स्टार प्रॉब्लम. आई वुड लाइक एवरीबडी टू वर्क आउट ऑन दिस. प्लीज वर्क आउट ऑन दिस. Okay, Manideep is also saying 11, fine. बॉयज एंड गर्ल्स, दिस एन इंटरेस्टिंग क्वेश्चन, स्टार क्वेश्चन है ये. मैं स्टार मार्क कर रहा हूं यहां पर, देखिएगा. You can expect similar questions in future. I want everybody to work out this interesting question. I'll give you 2-3 minutes of time. Please make a try, everybody. Mr. Khan, I think you have selected that answer 68.5, right? Page hit ratio, hit in memory 0.35 into 10 milliseconds, 10 nanoseconds, plus 0.65 into 100 nanoseconds, 68.5 straight away. Good evening, Waseb Untwala. बच्चों, I'm expecting that you are working this problem. बहुत इंपॉर्टेंट प्रॉब्लम है on page replacement. if you could work out correctly, then आप मान सकते हो कि you are comfortable with virtual memory page replacement. क्विक सॉर्ट, हाँ ठीक है, दैट्स वर्स्ट केस इज ऑर्डर ऑफ n स्क्वायर, एवरेज केस इज ऑर्डर ऑफ n log n. दैट्स राइट. Essentially ये क्वेश्चन में आई एम इंटरेस्टेड टू नो हाउ मेनी पेज फॉल्ट्स हैपन एंड हाउ मेनी पेज रिप्लेसमेंट्स आर हैपनिंग. दिस इज इंपॉर्टेंट. देखिएगा दोनों में फर्क है. पेज फॉल्ट्स बढ़ के हो सकते हैं, पेज रिप्लेसमेंट्स कम हो सकते हैं, या दोनों बराबर हो सकते हैं, लेकिन ऐसा ना हो कि पेज फॉल्ट्स कम हो या पेज रिप्लेसमेंट ज्यादा हो, ये नहीं हो सकता. तो ये क्वेश्चन में दीज टू थिंग्स आर इंपॉर्टेंट. Come on, boys and girls, I hope you are working on this problem. निकेत सिंह इज सेइंग 2 पेज फॉल्ट एंड 1 रिप्लेसमेंट. ठीक है भाई, मैं और थोड़ा वेट करूंगा, दूसरे बच्चों के रिस्पॉन्स देखेंगे. निकेत, उसके बाद हम स्टार्ट करेंगे डिस्कशन, क्योंकि क्वेश्चन डायरेक्ट नहीं है, थोड़ा इन्वॉल्व है. देयर आर सम इनहेरेंट कॉन्सेप्ट्स व्हिच यू हैव टू अप्लाई. Niket Singh is saying 2 page fault and 1 replacement. How about other people? Come on, take and game. Vasif, Manideep, Saurav Kumar, please work out. चलिए स्टार्ट करेंगे बच्चों. ए डिमांड पेड वर्चुअल मेमोरी सिस्टम यूजेस 16 बिट्स वर्चुअल एड्रेस. यहां पे लिख लेंगे डेटा. वर्चुअल एड्रेस इज इक्वल टू 16 बिट्स. तो इसका फॉर्मेट क्या होगा? पेज नंबर एंड ऑफसेट. पेज साइज 256. देखिएगा, पेज साइज 256 बाइट्स. 256 बाइट्स मतलब पेज ऑफसेट बना आपका 8 बिट्स. सो देयरफॉर दिस 8 बिट्स, मतलब पेज नंबर इज आल्सो 8 बिट्स. Page number is also 8 bit. Okay, you have to work on it. देखिएगा, and has 1 kilobyte of main memory. चलिए फिजिकल एड्रेस से लेकर फिजिकल एड्रेस स्पेस. फिजिकल एड्रेस स्पेस इज 1 किलोबाइट्स, मतलब आपका फिजिकल एड्रेस बनेगा 10 बिट्स. F and D 10 बिट्स है, राइट. दिस होल साइज इज 10 बिट्स. दिस ऑलरेडी नोन टू बी 8, मतलब फ्रेम नंबर आपका बना 2 बिट्स. फ्रेम नंबर बना 2 बिट्स. LRU page replacement is implemented using the list whose current status page number in decimal is as follows. तो ये आपका LRU पेज है, ये नेक्स्ट है, ये लास्ट है. मतलब मोस्ट रिसेंटली यूज 63 और लीस्ट रिसेंटली यूज दिस 17. फॉर ईच ऑफ द हेक्साडेसिमल एड्रेसेस इन द एड्रेस सीक्वेंस बिलो. मतलब ये आपका वर्चुअल एड्रेस है. हेक्साडेसिमल 16 बिट्स होगा ना, 4 डिजिट्स है हेक्साडेसिमल डिजिट. 4 into 4 16 बिट्स. ये these are all virtual addresses. These are all virtual addresses. So for each of these virtual address sequence given below, indicate the new status of the list, page faults if any and page replacements if any. Very interesting question. तो मतलब सबसे पहले हमें क्या करना होगा? For each of the virtual addresses we have to get the corresponding page number, क्योंकि हमें पेज रेफरेंस स्ट्रिंग चाहिए. पेज रेफरेंस स्ट्रिंग में पेज नंबर्स चाहिए. तो हर एक वर्चुअल एड्रेस से पेज नंबर निकालना होगा। देखेंगे कौन बताएगा मुझे। व्हाट इज द पेज नंबर प्रेजेंट इन द फर्स्ट वर्चुअल एड्रेस? कैन एनीबॉडी टेल मी दैट? देखेंगे व्हाट इज द पेज नंबर इन द फर्स्ट वर्चुअल एड्रेस। बच्चों बोलिए, बोलिएगा प्लीज। व्हाट इज द पेज नंबर इन द फर्स्ट वर्चुअल एड्रेस? एनीबॉडी? एनीबॉडी? व्हाट इज द पेज नंबर? वर्चुअल एड्रेस फॉर्मेट देखो बच्चों, वर्चुअल एड्रेस फॉर्मेट में पेज नंबर इज 8 बिट्स, 8 बाइनरी बिट्स, ऑफसेट इज 8 बाइनरी बिट्स, 8 + 8 16। तो ये आपको 16 बिट नंबर कन्वर्ट करना होगा हेक्साडेसिमल में, ठीक है। तो मतलब इफ यू टेक द फर्स्ट वर्चुअल एड्रेस, मैं यहां लिखूंगा 000 4 बिट्स, नेक्स्ट 000, दिस इज योर पेज नंबर, रिमेनिंग बिट्स इज ऑफसेट, रिमेनिंग बिट्स इज ऑफसेट, दिस पेज नंबर, दिस पेज नंबर। So first 8 bits are 0, मतलब पेज नंबर इज 0, पेज नंबर इज 0, ठीक है। यहां पर भी देखिएगा 4 बिट 0, 4 बिट्स 1, 4 बिट 0, 4 बिट 1, मतलब ये पेज नंबर क्या बना? ये पेज नंबर बना 1। फर्स्ट 8 बिट्स अगर आप लोगे पेज नंबर 1, ठीक है। नेक्स्ट क्या है देखिएगा 10FF। अब आप लिखिएगा, सो यहां पे मैं रिमूव कर दूंगा थर्ड का लिखने के लिए। सो 0001, 0 मतलब 0000, दिस माय पेज नंबर, फर्स्ट 8 बिट्स पेज नंबर, फर्स्ट 8 बिट्स। तो ये क्या हुआ 0 1 2 3 4, 2 पावर 4 16, ये 16 है, ये वैल्यू 16 है, इक्वलेंट। सक्षम इज करेक्ट। सो दिस 16। तो दिस इज 1 1 1 1, मतलब लास्ट में 1 आएगा, लास्ट में 1 आएगा, मतलब 16 + 1 17। इसमें पेज नंबर है 17, इसमें पेज नंबर है 17। तो मतलब फॉर दिस लिस्ट ऑफ वर्चुअल एड्रेसेस द पेजेस विच आर रेफर्ड आर 0 1 16 एंड 17। मतलब अगर हम यहां पे लिखेंगे रेफरेंस स्ट्रिंग, अगर यहां लिखेंगे रेफरेंस स्ट्रिंग, इट विल बी 0 1 16 एंड 17। और यहां पर हमें बनाना होगा डायग्राम फॉर पेज फॉल्ट्स। कितने फ्रेम्स है? क्या कोई मुझे बताएगा? फ्रॉम द डेटा गिवन हाउ मेनी फ्रेम्स आर देयर? देखेंगे कौन रिस्पॉन्ड करेगा। मेमोरी हैज हाउ मेनी फ्रेम्स? कम ऑन बॉयज एंड गर्ल्स, मेन मेमोरी हैज गॉट हाउ मेनी फ्रेम्स? हाउ मेनी फ्रेम्स आर allocated to the process? How many frames are allocated to the process, boys and girls? Anybody? Four frames. That's right. Why? Because simple point, frame number is 2 bits. So matlab 4 frames hai. These are the 4 frames. These are the 4 frames. Just I will reduce this. चलिए अब देखिएगा how are we going to work out LRU? I will simulate with a stack. This is my stack. LRU का सिमुलेशन हम स्टैक से करेंगे, ठीक है। We'll work out with a stack. Bottom of the stack is always LRU, मतलब 17 1 63. This is my current status of the frames. 17 1 63. तो आप कोई भी ऑर्डर में इन एनी फ्रेम यू कैन कीप एनीथिंग लाइक 17 1 63. LRU most recently used here. First I am referring page number 0. देखिएगा यहां पर we are referring page number 0. Will it cause a fault? Yes, it will cause a fault. But does that require any replacement? No, because I have empty frame, no replacement, so I bring 0. So 0 will come onto the top of the stack as MRU page. Next, which page are we referring? 1. Will it cause a fault? No, it won't cause a fault. it is already available. लेकिन क्या होगा, स्टैक मैनिपुलेशन होगा. wherever there is one will come on to top of the stack, one will come on to the top of the stack. मतलब 1 आएगा यहां पर, राइट, सबसे ऊपर आएगा, उसके नीचे आएगा 0, उसके नीचे आएगा 63, उसके नीचे आएगा 17. 17 remain LRU. स्टैक you have to show properly. फिर उसके बाद हम रेफर करेंगे 16. will it cause a fault? Because 16 is not present, it will cause a fault, and this will require replacement also. This will require replacement. तो LRU से कौन रिप्लेस होगा? 17 is LRU, तो 17 की जगह आएगा 16, फिर 1, 63, 0 as it is. तो आपका स्टैक मैनिपुलेशन क्या होगा? आपकी स्टैक कन्वर्ट हो जाएगी as follows. Right? So now 16 is on top, 1 will go 0, 63. So next time 63 is LRU page. Next time 63 is LRU page. तो उसके बाद देखिएगा आप 17 को रेफर करोगे. 17 will cause a fault and it will require replacement because no empty frame. So कौन replace होगा? 63. तो मतलब you will have 16, 1, 63 की जगह आएगा 17, 0. So this will be the sequence. So the pages in memory will be as follows. The pages in the memory will be as follows. So these are the pages present in memory. और उसका sequence अगर पूछ रहा है, sequence अगर पूछ रहे हो, sequence अगर पूछ रहे हो, this is the pages in memory. I don't know what is happening. Okay. Fine. These are the pages in memory. लेकिन अगर सीक्वेंस LRU सीक्वेंस में अगर आप लिखोगे, ये लिखना पड़ेगा, राइट? So LRU is 63. So you'll have to write like this: 63, then followed by 1, 0, followed by 1, followed by 16. 16 or 17. Sorry. So 63 has been replaced. So in place of that, 17 has come onto the top. 17 has come onto the top. Okay. So list will become like. Bottom is 0, LRU 1, 16, 17. तो आपने ऐसा बनाना होगा डायग्राम. सो यहां पर आप लिखोगे दिस इज LRU. तो आंसर आपकी लिस्ट क्या होगी? द न्यू स्टेटस ऑफ द लिस्ट इज लाइक दैट: 0, 1, 16, 17. 0, 1, 16, 17. दिस इज योर लिस्ट. मतलब यही सीक्वेंस में रहेंगे. वट एवर इज द रेफरेंस थिंग, इट विल बी द सेम सीक्वेंस. 0, 1, 16, 17 वही सीक्वेंस में. दैट इज द ब्यूटी ऑफ द क्वेश्चन. पेज फॉल्ट्स इफ एनी, हाँ 3 पेज फॉल्ट्स. पेज रिप्लेसमेंट्स इफ एनी 2 रिप्लेसमेंट्स. ये है आपका आंसर. ये है आपका आंसर. 17 is MRU, 16 is next, and last is 0. बोलिए बच्चों, इज इट ओके, इज इट क्लियर? क्या प्रॉब्लम क्लियर है? कम ऑन. इज एवरीथिंग ओके? ओके. Next, we will talk about the concept of thrashing, as I mentioned in my last class. What is thrashing? By definition, thrashing is excessive or high paging activity. High paging activity. Paging activity का मतलब यह है the activity of page faults that involve page replacements. The act of causing a page fault which will result in saving the page and loading the faulted page, that is called paging activity. So when page fault rate shoots up, जब पेज फॉल्ट रेट काफी हाई हो जाएगी सिस्टम में, वो स्टेट को हम जनरली थ्रैशिंग बोलते हैं. थ्रैशिंग इज अनडिजायरेबल. थ्रैशिंग इज एन अनडिजायरेबल फीचर. वी नेवर वांट ए सिस्टम टू थ्रैश. व्हाई इज इट अनडिजायरेबल? बिकॉज व्हेन थ्रैशिंग अकर, प्रोसेसेस गेट ब्लॉक्ड. प्रोसेसेस गेट्स ब्लॉक्ड. So thereby utilization or throughput levels will come down. Utilization or throughput level drops. CPU utilization, throughput levels will come down. That's why we say thrashing is an undesirable feature. So that means we need to have concrete strategies for dealing with the problem of thrashing. But before we come to the concrete strategies for discussing strategies, we need to understand what are the potential reasons for the system to thrash. The important reasons for the system to thrash is lack of memory, lack of frames to processes. And this lack of frames happens, frame allocation comes down for the processes. Processes का frame allocation कम हो जाएगा. कब होगा? कम होगा because of high degree of multiprogramming. Because of high degree of multiprogramming. When too many processes are injected into the system, then naturally the lack of frames will happen, and that invariably is going to increase the page fault rate. This phenomena can be shown diagrammatically. I am sure you remember that diagram. So on the x-axis, as you increase the degree of multiprogramming, as you increase the degree of multiprogramming on x-axis, I say percentage CPU utilization. Percentage CPU utilization will also increase. It will reach some top, and after that it declines and drops. So this area is demarcated as thrashing state. ये आपका thrashing domain है. So here you are going to achieve the highest degree of highest utilization of CPU at this degree of multiprogramming. ठीक है? There are other reasons also for the system to thrash. Other reasons. What are the other contributing reasons? Like for example, page replacement policy. Page replacement policies. If I don't use a good replacement policy, it will lead to more page faults. Selection of page size will also impact thrashing. अगर आपकी पेज साइज स्मॉल हो, नंबर ऑफ पेजेस विल बी मोर, इट विल लीड टू मोर पेज फॉल्ट्स. उसी तरह प्रोग्रामिंग टेक्निक्स एंड डेटा स्ट्रक्चर्स, इंपॉर्टेंट टॉपिक. रेस्पॉन्सिबिलिटी ऑफ प्रोग्रामर्स. तो यहां पर हमने डिस्कस किया था क्लास में, इफ यू रिमेंबर, in detail, and based on that there was a question in GATE 2023, if you remember. Programming techniques and data structures. If you don't use proper techniques, it will increase the page fault rate. हमने practically double dimensional array से demonstrate किया था, और similar question 90%, 95% similarity के साथ GATE 2023 में question आया था. You can check that. So that is programming techniques and data structures. Then question arises, how to control thrashing. How to control thrashing. Thrashing control strategies. बोलिएगा please. How do you control thrashing? So we can say basically there are two approaches, just like as we deal with deadlocks. Maybe we can say prevent, and the other is detection and recovery. These are the two approaches of dealing with thrashing. So can anybody tell me in the chat box, how do we prevent the system from going into thrashing state? Come on, tell me. How can we prevent the system from going into thrashing state? बोलिए बच्चों. How can we prevent the system from going into thrashing state? System can be prevented by controlling degree of multiprogramming by making sure that the degree of multiprogramming is in or around that maximum limit where I have highest utilization. So this is prevention. Detection is done by low utilization of CPU, low CPU utilization, plus high degree of multiprogramming, plus हाई डिस्क यूटिलाइजेशन, डिस्क जहां से आप पेजेस लोड कर रहे हो, स्टोर कर रहे हो, हाई डिस्क यूटिलाइजेशन. ये 3 कंडीशन जब आप ऑब्जर्व करोगे, दे आर होल्डिंग, इट कंफर्म दैट सिस्टम इज थ्रैशिंग. Then how to recover the system from thrashing? Recovery is done by applying a concept called process suspension. Move out the process, swap out the process from main memory onto disk. क्योंकि आपकी degree of multiprogramming reduce करना है, so suspend the processes. So boys and girls, these are the 2 approaches for dealing with thrashing. Lastly, I would like to tell you that there is another approach or model that is generally used for controlling thrashing. And that is called working set model. ठीक है? Working set strategy or working set model. An important topic. ठीक है? I'm not going to discuss the whole thing. I will just give you a glance through of working set strategy. The working set strategy, the basic objective of working set strategy is not only control page fault rate, but also utilize memory effectively. That is what working set strategy would achieve. It controls thrashing, page fault rate, and also utilize the memory better. By following the concept of dynamic frame allocation. The working principle of working set model is based on the philosophy of locality of reference, or locality model is based on the concept of locality model. That means most of the time the programs exhibit locality of execution. Matlab, it will always be in a particular locality, where locality can be a function, procedure, block or data structure. So basic idea जो है locality का, कि जो भी locality में program, ठीक है, जो भी प्रोग्राम आप एग्जीक्यूट कर रहे हो वो पर्टिकुलर लोकेलिटी में रहेगा, ठीक है? लाइक मेन फंक्शन है, फंक्शन एफ है, फंक्शन जी है. तो आइडिया इज, इंस्टेड ऑफ लोडिंग रैंडमली सम पेजेस, यू लोड द पेजेस ऑफ द करंट लोकेलिटी इन विच यू आर, सो दैट पेज फॉल्ट रेट इज मिनिमम, एंड एट द सेम टाइम the memory utilization will also be better, because you will hold only the pages of that locality in which you are executing. मतलब मान लीजिए, for example, if I have some function main is calling function f. सिर्फ 2 एग्जाम्पल लेंगे. main is calling f. For example, imagine for main का size है 20 KB and function f का size है 5 KB. Let us imagine page size is 1 KB. तो मतलब your main function fits in 20 pages, and then this will fit in 5 pages. तो हमारा कॉन्सेप्ट ये है कि as long as I'm executing in function main, I should have 20 pages. The moment I change my locality, when I call function f, locality changes from main to f. तो हमें डिटरमिन करना होगा what is the size of locality of function f, and accordingly ask those many pages. So now my locality changes from 20 to 5. So I will not hold 20 frames, I will hold only 5 frames. That is the basic core idea of locality model. लेकिन इसका मेजर चैलेंज यहां पर यह है, हाउ आर वी गोइंग टू एस्टिमेट द साइज ऑफ लोकेलिटी? दैट इज डन थ्रू ए पैरामीटर, a conceptual parameter called working set window. I cannot have time here to explain everything. I'm just giving a brief review of it. Working set window, WSW. हर प्रोसेस के लिए वर्किंग सेट विंडो डिफाइन करेंगे. एज पर द डेफिनेशन इट रेफर्स टू द पास्ट डेल्टा रेफरेंसेस of the process which has been referred. Past delta. Delta is a parameter which you have to guess. तो मतलब हर प्रोसेस का वर्किंग सेट विंडो साइज आपको डिटरमिन करना होगा, and then you have to see what is the sum of the all working set windows. If that is less than or equal to number of frames available, there is no problem, no thrashing. लेकिन sum of working sets if it is greater than the number of available frames, मतलब आपको कंफर्म करना पड़ेगा कि सिस्टम इज थ्रैशिंग. तो सिस्टम थ्रैश हो रहा है, then you have to recover by process suspension. You will have to swap out the process. ये है एक बेसिक रिव्यू विथ रिगार्ड टू वर्किंग सेट स्ट्रैटेजी. तो बच्चों, दिस इज द डिस्कशन, टोटल डिस्कशन ऑन वर्चुअल मेमोरी आइडियोलॉजी, वर्चुअल मेमोरी कॉन्सेप्ट. ठीक है. सो यू प्रिपेयर ऑन दीज लाइन्स. जो टॉपिक्स हम डिस्कस किए, सॉल्व द प्रॉब्लम्स. आई एम वेरी श्योर इट शुड सर्व योर पर्पस. अब नेक्स्ट हम स्टार्ट करेंगे फाइल सिस्टम, जहां पर सबसे पहले नेम ऑफ द टॉपिक यहां पे लिखेंगे. नेम ऑफ द टॉपिक लिखेंगे फाइल सिस्टम. गॉड, and device मैनेजमेंट. चलिए, ये है हमारा डिस्कशन. ठीक है. फाइल सिस्टम एंड डिवाइस मैनेजमेंट. ओके. Working set is a model. It is a conceptual, theoretical model. It need not be implemented in every OS. Tech and games. A problem is split into sub problems and the sub problems are solved. देखिएगा, ये स्ट्रैटेजी एप्लीकेबल होगी डिवाइड एंड कॉन्कर में भी और डायनेमिक प्रोग्रामिंग में, दोनों में एप्लीकेबल है. करेक्ट है आपका ऑप्शन, आपका आंसर बिल्कुल सही है. ठीक है. चलिए, फाइल सिस्टम इज सपोज टू बी द विजिबल पार्ट ऑफ ऑपरेटिंग सिस्टम, विजिबल पार्ट ऑफ ओएस. यू कैनॉट सी प्रोसेस रनिंग ऑन सीपीयू. ठीक है. बेस्ट पॉसिबल ऑप्शन, यू शुड गो फॉर डिफॉल्ट डिवाइड एंड कॉन्कर. अगर एक ही ऑप्शन सेलेक्ट करना है आपको, तो जनरली यू शुड गो फॉर डिवाइड एंड कॉन्कर, बिकॉज दैट इज द बेसिक फिलॉसफी. डिवाइडिंग द प्रॉब्लम इनटू सब प्रॉब्लम्स इज द इनहेरेंट कैरेक्टरिस्टिक ऑफ डिवाइड एंड कॉन्कर. क्योंकि डायनेमिक प्रोग्रामिंग में ओवरलैपिंग सब प्रॉब्लम भी होना चाहिए. ठीक है. चलिए, you cannot see process running on CPU, you cannot see process performing IO operation, you cannot see process residing in memory, right? In that way, process management is not visible to human eye, memory management is not visible to human eye. Lekin file system is visible part. You can see the file, you can see the contents of file, you can see the contents of directory. In that regard, we say file system is a visible part of operating system. Now, before we study the aspects related to file system design, it is quite essential to understand where exactly file system reside. आपको पता है file system is basically a software to manage secondary storage or mass storage devices. Mass storage devices like hard disk, pen drive, DVDs, etc. So boys and girls, this is the CPU and this is a secondary storage device like disk, hard disk, you can imagine. This electronic device is electromechanical. Okay? Electronic and electronic. So to harmonize the architectural mismatches between the two types of devices, we require an interface like SATA card. Okay? IDE or SATA, something like that. Then to manage this, we'll have a device driver. And then we'll have the device manager DM. And here we have the file system FS. So this is the architecture. So as such, in this chapter, you have to study about the characteristic of disk and the characteristic of file system, like this. So by studying characteristic of disk, I mean you need to study the physical geometry of hard disk, physical structure, and you also need to learn logical structure. Logical structure, I mean formatting process. When you format a disk with any file system like NTFS FAT32, what is going to happen? Okay? So that is physical structure and logical structure. So as part of physical structure, I am sure this you know it, that this is how the disk would look like. Disk is a collection of platters. Platters are wound around the spindle. यहाँ पर center में spindle रहेगी. बता रहा है spindle. So it is the disk platter or disk. This is actuator or arm, and then this circuit board, the read-write head. All the components are shown in this diagram. Yes, Tech and Games is saying everybody is using PCI X NVMe SSDs. That is correct. Okay, SSDs are in use. Okay. Another view of hard disk. And this is a logical structure. Logically, you can see the disk like this. It's a collection of platters. Every platter has got two surfaces, surface 1, surface 2, top and bottom. This is the spindle about which your rotations are made. And this is the disk arm or assembly, right? And this is the arm or assembly. And this will make a linear motion like this. And this will make angular motion like this, rotate or revolve. So these are sequential tracks. The platter surface is divided into tracks, tracks into sectors. So tracks, sectors. And the same track number when referred to on platter surfaces is called cylinder. So ये organization काफी important है बच्चों. Based on this, there were many questions asked in earlier papers. ठीक है? Like here I would write. Hard disk is a collection of platters first. Each platter has got two surfaces. Surface is divided into tracks. Tracks is divided into sectors. A group of sectors is also called cluster. And the same track number when I referred on each platter surface, that is called cylinder. ये हमारा physical structure है या physical geometry of hard disk. Hierarchy is this. Disk is divided into platters, platters into surfaces, platter has two surfaces, each surface is divided into tracks, tracks into sectors. A group of sectors is called a cluster. And sector or cluster sector or cluster is what is termed as unit of transfer. So this is unit of transfer between memory and disk. जो आप डेटा ट्रांसफर करोगे मेमोरी और डिस्क के बीच में, that is in the form of clusters or in the form of sectors. ये बेसिस पर हम जनरली रिवाइज करेंगे ऑन द कॉन्सेप्ट ऑफ IO टाइम, डिस्क इनपुट आउटपुट टाइम to read a sector or write a sector. It consists of 3 different times. बोलिएगा बच्चों, what are the 3 different times? From your previous knowledge or previous study, can you tell me what are the 3 components that constitute for disk input output time? बोलिए, disk input output time के 3 components है, what are they? Correct, Saurav Kumar. One is called seek time. Generally we write in short ST. Time needed to seek from the current track to the desired track by read-write head. That is called seek time. Generally seek time is taken as some average value that will be given in the question most often. फिर उसके बाद आपने ऐड करना है rotational latency और rotation time. Rotational latency or rotational time we generally write RT. Rotational latency. Amount of time needed to rotate the platter surface so that the start of sector comes under read write head. जो start of sector है वो read write head के अंडर आना चाहिए, वो है rotational latency time. फिर उसके बाद transfer time. Time needed to transfer the data TT. This will depend on sector size, track size और फिर rotation rate. हर डिस्क का अपना एक पैरामीटर होगा, एक मेट्रिक होगा जिसका नाम है RPM, that stands for rotation per minute. Rotation per minute that indicate the speed of disk. जैसे 3600 RPM अगर हम बोलेंगे तो मतलब यहां से हम टाइम फॉर वन रोटेशन R निकाल सकते हैं. 60 divided by 3600 seconds. This is your time for one rotation. That will come around 16.6 milliseconds. ठीक है, that is RPM and rotation time. तो बच्चों, these are the 3 different times which are taken into consideration for performing IO operations. ठीक है. Then last metric, performance metric is called DTR, data transfer rate. Data transfer rate. DTR. What rate are we transferring the data? That indicates the speed of disk. That is correct. Rotational latency, generally if it is not given how much we have to rotate, it is taken as time for R by 2, rotation time divided by 2. Rotational latency का ये convention. तो चलिए बच्चों, based on this physical geometry, let us work out a simple problem. Let us work out a simple problem. एक question ले लेते हैं यहाँ पर. Suppose imagine my disk has 32 platters and platter surface has 512 tracks. Each track has 2048 sectors. Each sector is of size 4096 bytes. Average seek time is 30 milliseconds. RPM is 6000. ठीक है. In respect of these specifications, with respect to these specifications, I want you to compute the following. Disk capacity of disk. Number second, input output time for one sector. Third, DTR. So I'll give you 3-4 minutes of time. I want you to work out. I mean, number of surfaces by default it is 2. Every platter will have 2 surfaces. That is the norm. चलिए वर्कआउट कीजिएगा बच्चों, ये क्वेश्चन वर्कआउट कीजिएगा एवरीबॉडी. Come on, do it. Don't make mistakes. Okay, Saurav Kumar is saying 256 GB. Okay, Tech and Games is also saying 256 GB. Very good. Come on, others also please work out. Others also please work out. IO टाइम भी वर्कआउट कीजिएगा प्लीज, DTR भी वर्कआउट कीजिएगा एंड टेल मी ऑल रेस्पॉन्सेस. अदर टू क्वेश्चन मीन्स इनपुट आउटपुट टाइम एंड DTR. इनपुट आउटपुट टाइम का फॉर्मूला हमने कहा था सीक टाइम प्लस लेटेंसी टाइम प्लस ट्रांसफर टाइम. फॉर्मूला यूज कीजिएगा फरहान खान. Okay, 30.01 milliseconds. So let's see here. This capacity पहले calculate करें. There are 32 platters. Each platter has got two surfaces. Each surface has got 512 tracks. Each track has got 2K sectors. Each sector is of size 4 KB. तो ये है आपकी डिस्क की कैपेसिटी. स्ट्रेट अवे मल्टीप्लाई करना. सो दिस इज 32 into 2 64, मतलब 2 raised to 6. into 2 raised to 9 into 2 raised to 11 into 2 raised to 12. तो कितना बनेगा ये 20, 26, 28, 38, 2 power 38, 256 GB. वेरी करेक्ट, 256 GB इज करेक्ट. चलिए अब इनपुट आउटपुट टाइम पे आएंगे. विल वर्क आउट IO टाइम, सीक टाइम, लेटेंसी टाइम, ट्रांसफर टाइम. सीक टाइम इज गिवन 30 milliseconds. Is it not 30 milliseconds? देखिएगा 6000 rotations are made in 60 seconds. So one rotation take how much time? So 60 divided by 6000. So this will become 1 by 100, 0.01 seconds. 0.01 seconds. 0.01 seconds is equal to how many milliseconds? 1 millisecond is equal to 1000 millisecond. आप इसे 1000 से मल्टीप्लाई करें तो 10 millisecond होगा. 10 millisecond. Correct? So 10 मतलब 5, 10 by 2, 5 millisecond is rotational latency. So seek time plus latency. Now transfer time. Transfer time. Transfer time कैसे करेंगे देखिएगा. Track size, one track size यहां पे निकालेंगे. Track size equal to these many sectors of this much size. मतलब 2K sectors, each of size 4 KB. मतलब ये हुआ 8 MB. 8 MB. ट्रैक साइज इज 8 MB. सो एक रोटेशन टाइम में आप यू कैन रीड होल ट्रैक. इफ आई मेक वन रोटेशन ऑफ द डिस्क आई कैन रीड होल ट्रैक. रोटेशन टाइम इज 10 milliseconds. मतलब 8 megabytes ऑफ डेटा इज रीडेबल इन 10 milliseconds. हमें इसमें से सिर्फ ट्रैक रीड करना है ऑफ साइज 4 KB. ट्रैक नहीं, सॉरी, सेक्टर 4 KB. तो 4 KB नीड्स हाउ मच टाइम? सो 4 KB इंटू 10 डिवाइडेड बाई 8 MB. This goes K time 2. So this will become 10 by 2048, which is a very small value. 10 by 2048 milliseconds. So boys and girls, this is the total input output time. 35 plus something. You can roughly take 35 milliseconds. This is almost negligible. 35 milliseconds. अब रही बात डेटा ट्रांसफर रेट. डेटा ट्रांसफर रेट इज मेजर्ड इन बाइट्स पर सेकेंड. कहां से निकालेंगे? यहीं से निकालेंगे. देखिएगा, प्लीज हैव अ लुक. 8 megabytes ऑफ डेटा इज रीडेबल इन 10 milliseconds. 10 millisecond मतलब 10 into 10 power minus 3 seconds. ठीक है. सो इन 1 second how many bytes are readable? So this will become 8 megabytes into 10 power 3 divided by 10 per second, which is roughly 0.8 mega into 10 power 3 is gigabytes per second. So this is roughly 0.8 gigabytes per second. ये है आपके आंसर्स. ये आपके आंसर्स है. Yes, 800 megabytes per second. That's correct, Saksham. Narottam Devri is saying after seeing the second, very good. How have you performed, Narottam? कैसा लिखे आप एग्जाम? गुड, वेरी गुड. तो चलिए बच्चों अब आगे बढ़ेंगे. विल गो ऑन टू नाउ looking into a topic called file system interface. We'll look into a topic called file system interface. File system interface. File system interface. There are two parts in file system. One is file system interface, the other is file system implementation aspects. So in the interface part, we have to look into the concept of file, the concept of directory, directory structures, वो हम देखेंगे. फिर implementation aspects हम next class में देखेंगे as a new chapter. देखिएगा, file is a collection of logically collection of records. Logically collection of logically related records. Logically related records is a file. That records may contain data of different types. Like for example, the type of data can be numeric, character, binary, or it may be a program consisting of instructions and data. Contains many types of time. I can have a text file, I can have a source file, I can have executable file. ये है different types of files. Then every file has an ADT. यहाँ पर हम लिखेंगे. File as an ADT. File as an ADT is associated with operations and attributes. Is associated with operations and attributes. Like what are the different attributes that a file may be associated? File can have a name, can have an identifier, can have type, regular file, special file, etc. Location, where it is located on disk, size, protection information, time and date stamps, information about files are kept in directory structure. So all these attributes of a file, जैसा process के attributes रहेंगे वैसे file के भी attributes रहेंगे. Attributes of process is kept in PCB, उसी तरह attributes of a file are kept in FCB, file control block. File control block is known by different terms in different file system. Like for example, in Unix it is called inode, and in other file systems it is called directory entry. ये points याद रखना है आपने. Inode and directory entry. This is how the attributes of the file look like in Mac operating system 10. Mac 10. These are the attributes. Likewise in Windows also, when you right click the button and then check the dialog box, you would see all the attributes of the file. Then what is a directory? Or before directory, I think file operations भी कहीं होना चाहिए. हाँ, ये file operations पहले देखेंगे. What are the operations that we generally perform on files? Like we create the file, we open the file, read from the file, write to the file, append to the file, truncate the file, modify the contents of the file, and finally close the file and delete the file. लेकिन point मुझे ये बताना है आपको कि these operations are generally performed at two levels. Either you can perform at the command level through commands or through system calls. Through system calls, that is API. Command level again in two forms, either through textual commands or maybe through GUI operations. Either way. Either through text, you type the text on the shell, or through GUI. Or you can use system calls in programs. So this will be used in programs. In programs. So that's about opening a files. What are the different types of files? As you know it here, you can check. We have executable file, object file, source file, like .c, .cc, .java, .pascal, .assembly, .a, .batch, text files, mod processor file, library files, print file, archive files, multimedia files. So many types of files. File structure can be a simple no structure, record structure, hierarchical structure, complex structures. So therefore every file should have some file structure. Access methods. We can have the following access methods: sequential or direct. So either it can be sequential access or it can be a direct access, or it can be a mix of other access methods also. Sequential access will be slow access. Direct access is faster. Generally this is supported on direct devices like disk, and this is generally followed on magnetic tapes. Magnetic tapes. So sequential access का example है यहाँ पे देखिएगा. जब भी आपको कोई data read करना है, you have to always start reading from beginning. So the direct access will be faster access. Then we have index sequential access and other access methods like index. That's what I told. इंडेक्स सीक्वेंशियल एक्सेस एक्सेट्रा, दिस इज एन एग्जांपल ऑफ दैट। ये तो फाइल्स का सिस्टम ऑर्गेनाइजेशन है, ये हम बाद में आएंगे। डायरेक्टरी पे आएंगे। व्हाट इज डायरेक्टरी स्ट्रक्चर? डायरेक्टरी इज अ प्लेस होल्डर ऑफ फाइल्स। डायरेक्टरी इज अ स्पेशल फाइल। Okay, very good. Directory is a special file, and directory contain attributes information, attributes of the file. Attributes information of files is kept as data in directory. That is why we say directory contain metadata of files. Metadata of files. So files directory में नहीं रहेंगे, फाइल का इंफॉर्मेशन रहेगा डायरेक्टरी में। यह है इंफॉर्मेशन, दिस इज मेटाडेटा इंफॉर्मेशन। इंफॉर्मेशन अबाउट फाइल 1, इंफॉर्मेशन अबाउट फाइल 2, इंफॉर्मेशन अबाउट फाइल 3। फाइल्स तो अपनी जगह है डिस्क पर, उसका इंफॉर्मेशन ये डायरेक्टरी में है। दिस इज द कॉन्सेप्चुअल व्यू ऑफ डायरेक्टरी। चलिए आगे देखेंगे। डायरेक्टरी के अपने ऑपरेशंस रहेंगे। सबसे ज्यादा इंपॉर्टेंट ऑपरेशन जो डायरेक्टरी का है वो है सर्चिंग ए फाइल। सर्च ऑपरेशन इज अ वेरी पॉपुलर ऑपरेशन परफॉर्म्ड ऑन डायरेक्टरीज, जिसके लिए जनरली जो हम डेटा स्ट्रक्चर्स और टेक्निक्स यूज करेंगे वो है डेप्थ फर्स्ट सर्च, ब्रेडथ फर्स्ट सर्च। जनरली these सर्चिंग टेक्निक्स आर यूज्ड टू सर्च फॉर फाइल्स इन डायरेक्टरीज। ठीक है। Otherwise, other searching techniques like you can use linear search or binary search, so on. Then what are the other operations which can be performed in directory? Like you can create a new file in directory, you can delete a file from directory, you can list a directory, you can rename a file, you can traverse the whole file system. So these are the operations generally that we perform on directories. Next, देखिएगा एक डायरेक्टरी स्ट्रक्चर्स। नेक्स्ट हमारा टॉपिक होगा डायरेक्टरी स्ट्रक्चर्स। सो लेट मी राइट डायरेक्टरी स्ट्रक्चर्स। गलत हो गया। Directory structures. So this is a point. So the first and foremost simple directory structure is called single level directory structure. Single level directory. That means the whole system will have one directory. These are the files, directory files. इसके प्रॉब्लम्स है नेमिंग प्रॉब्लम। आई कांट हैव टू डिफरेंट फाइल्स विद द सेम नेम। ग्रुपिंग प्रॉब्लम होगा। आई कांट हैव प्रोजेक्ट्स, कॉमन प्रोजेक्ट्स, पीपल वर्किंग ऑन कॉमन प्रोजेक्ट्स। आई कैन नॉट ग्रुप देम इनटू फाइल्स। टू अवॉइड दैट यू कैन गो फॉर टू लेवल डायरेक्टरी स्ट्रक्चर। So first I have user level directory structure, next I have user subdirectory. This is the subdirectory of user 1, subdirectory of user 2, user 3 and so on. So here we will have the concept of path name, can have the same file name for different users. Efficient searching, no grouping capability still. अगर आप grouping capability पे जाना चाहोगे, then I need to have a hierarchical structure which is also called tree structure directory. So now the files are organized in the form of a tree structure. So this is the one of the most efficient directory structures, which is generally used in most of the file systems. फिर acyclic graph directory structure, no cycles to make the search efficient. Then general graph directory structure last में, मतलब you can have cycles here. So you can check there is a possibility of cycle. Cycle जब भी होगी traverse operation में आपने ये ensure करना होगा कि program should not go into infinite loop. That is general graph directory structure. So this is just for information purpose, right? These are all the other protection aspect, like type of access you can provide for a file, read only, write only, execute only, append, delete, list. So these are, the operations are available in the form of system calls, in the form of commands to perform these operations of ensuring protection on the file system. These are various examples which you can, this is a sample listing of files in the case of Unix operating system. Okay? These access control list management in like Windows operating system. Like that, the aspects are there. Next aspect which I would like to touch upon and give you is the logical structure of disk, जिसके basis पर हम नया chapter start कर सकते हैं. Logical structure ऑफ डिस्क, थोड़ा यहां डिस्कस करेंगे। लॉजिकल स्ट्रक्चर का मतलब है फॉर्मेटिंग प्रोसेस। As you know, any disk before storing the data, yes, tech and games, you can use hashing also. लेकिन हैशिंग का एक मेन प्रॉब्लम होगा कोलिजन्स को रिजॉल्व करने के लिए फिर आपको कुछ क्राइटेरिया यूज करने पड़ेंगे, टेक्निक्स यूज करने पड़ेंगे, जैसा चेनिंग है या प्रोबिंग है एक्सेट्रा। ठीक है, तो लॉजिकल स्ट्रक्चर फॉर्मेटिंग लाइक NTFS FAT32 से आपको फॉर्मेट करना होगा। सो व्हेन यू फॉर्मेट ए डिस्क और डिस्क पार्टीशन विथ एनी file system like NTFS or FAT32, what typical data structures are embossed or created onto the disk partition, ये हमें देखना होगा। ठीक है, तो यहां पर मैं आपको ब्रीफली थोड़ा आउटलाइन करूंगा। पॉइंट नंबर 1, we generally divide our disk into logical units called partitions by using some facilities like fdisk, एक कमांड है, by means of that you can create partitions and you name the partitions like C:, D:, E:. So these are called partitions. Partitions are of two types, primary and extended. Primary partitions are bootable. These are non-bootable. You can have one or more primary partitions. For Farhan Khan, we have to take a problem. हमारे regular course में we solve question taking that जैसा multi-level structure of inode concept. There you can measure how many disk accesses are needed. Okay. So for every level I need one disk access for every level. चलिए start करेंगे. So these are partitions. All can be primary partitions. So if I have all different partitions as primary partitions, I can load different operating systems onto it. I can have one operating system here, another operating system here, another operating system here. So every partition must be formatted with some file system. So when we format any disk partition with any file system, typically what data structures are created onto it? Typically, तो यहां पर हम देखेंगे, one is called PCB directory structure. So this is called boot control block. This is called partition control block. Partition control block. And here I have the directory structure. Here I have the directory structure. Last में हमें हमारे रहेंगे data blocks. Last में रहेंगे data blocks. इस तरीके से data blocks. ठीक है, the partition structure ये काफी इंपॉर्टेंट है. There were questions in earlier papers based on this organization. So in case if the partition is bootable, यहाँ पर first operating system bootable program रहेगा. जैसा Unix अगर operating system हो तो हम बोलेंगे init program, या Windows or other operating system like kernel.exe. First operating system program needed for booting will be stored here. Partition control block is like the administrative block of disk. It is also called super block in Unix, master file table in Windows, like operating system. मतलब this will give information about the whole disk partitions or whole disk blocks. पूरे disk blocks का information यहाँ रहेगा, जैसे कि how many blocks are free, how many blocks are in use, how many blocks are bad. Complete information about the disk blocks of the partition are kept here. अगर ये corrupt हो गया मतलब आपका disk partition lost हो गया. You will have to reformat the disk. Directory structure, single level, two level, multi-level directory structure यहाँ रहेंगे. Then these are the data blocks. So managing the disk space means managing these disk blocks. For what purpose? Like for allocation, for deallocation, for free space management, and so on. That is what. So that is actual file system implementation. देखिएगा, somebody is asking MBR. MBR will always be stored on the first primary partition at some fixed place. At some fixed place. ऐसे store रहेगा MBR. Master boot record. It is the master boot record which play a role in booting. जब आप power on करोगे system, the very first program that runs is post power on self test. फिर उसके बाद BIOS, ठीक है, फिर उसके बाद bootstrap. Bootstrap will load this MBR into main memory. This MBR will have two parts. This MBR will have two parts. Partition table that gives information about all partitions, and bootloader. So this bootloader, based on the selection made by the user, it will load the corresponding operating system from the disk partition into main memory. So that's how booting continues. So ये है बच्चों the overall discussion with regard to disk logical structure and disk physical structure, and also the interface in the form of files and directories. ये आज का हमारा discussion है with regard to file system interface and also some basics of virtual memory concepts. तो अब जो टॉपिक बचा हुआ है जो हमें डिस्कस करना है वो है implementation aspect of file system regarding this data block, user data block management. So how are we going to manage those blocks, particularly in terms of allocation, deallocation, free space management, and so on? We shall take up that discussion as a new lecture in the next class, and that will be the last class, last topic, last class. So जहाँ पर हम file system implementation aspect देखेंगे along with disk scheduling, need for disk scheduling discuss करेंगे, and we'll have a brief review with regard to various disk scheduling techniques and the parameters that influence the disk scheduling techniques. ये हमारा लास्ट क्लास का डिस्कशन होगा. तो चलिए, बिफोर वी क्लोज, इफ यू हैव एनी क्वेश्चंस टू आस्क, वी हैव टाइम another 2-3 minutes or 3-4 minutes. We can discuss something about your queries, about your doubts. बोलिएगा. If you have any specific questions regarding GATE, regarding academics, you can post it in the chat box. बोलिए. From my side, I would like to tell you a few things which are primarily important as far as your career growth is concerned, right? Career के लिए, career के perspective से generally मैं ये कहूँगा कि you concentrate, particularly those who are in second year and third year, you concentrate first on your verbal abilities, aptitude abilities, numerical aptitude, verbal aptitude, problem solving skills development, right? This is very, very important. ये बहुत ज़्यादा important है. Then your focus should go on to technical side. Technical side में आपने अपना stronghold बनाना है, subject knowledge. Anyway आप subject पढ़ रहे हो, आपका subject strong होगा. Then the other aspect which you have to focus is on programming side, coding पर improve कीजिए. Coding में सबसे पहले versatility develop कीजिएगा, learning the language. फिर उसके बाद you will have to go for data structures programming, फिर उसके बाद algorithms programming, फिर उसके बाद competitive programming. ये करिएगा. Try to solve some problems at least from the competitive programming platforms like HackerRank or LeetCode or Codeforces and others. वहां से कीजिएगा. That's very important. और इसके साथ साथ those who are in second year and third year, I would recommend that you do some internships to build up your technical profile. Internships करने के लिए, particularly in some academic institutions like IITs, IIITs and NITs offer summer internship program for 2 months, जहाँ पर आपको technically देखा जाएगा with regard to coding and also with regard to this web development frameworks, right? Like full stack development and server side and client side programming skills, they look into it. उसमें वहाँ पे generally internships offer किए जाते हैं. So these aspects you should think of. Right? So this is what is expected, and those who are definitely planning for higher studies in MTech, I would recommend you should concentrate on coding and building your strong mathematical abilities. Farhan Khan, you are saying what are the gaps for operating system research? There are still a lot of work to be done, particularly in mobile operating system, advanced operating system, distributed operating systems, right? Particularly leading to say catering to the requirements of synchronization and distributed computing. There are still a lot of scope. जो थ्योरी यहाँ रह जाती है वो पढ़ना है, हाँ बिल्कुल. Yes, ARM based is also a good idea to explore for further research. देखिएगा कितने टेस्ट, नंबर ऑफ टेस्ट. I mean, it all depends on you. Minimum 5 to 6 mock tests you should give. Yes, placements are poor, so it is better to think of other avenues, other opportunities. Like as I said, best possible is MTech. Go for MTech, either in India or abroad. Okay, very good. ओके, LRU का क्वेश्चन था आज के पेपर में. फाइन. जनरली बच्चों NIC और इसरो का पेपर काफ़ी सिंपल होता है. वी डोंट हैव टू वरी मच अबाउट इसरो एंड NIC पेपर. एंड फ्रैंकली स्पीकिंग गेट का भी फॉर द पास्ट कपल ऑफ ईयर्स सम क्वेश्चंस आर वेरी लड्डू एंड हलवा क्वेश्चंस इन गेट, अनलाइक अर्लियर ओकेशन जब 2000 अप टू फ्रॉम 99, you can say 98, 99, 2000, 2001, 2002 up to 5, questions were really challenging in GATE. But nowadays, some questions are really very simple in GATE. ठीक है, that's good. Okay, boys and girls, any other thing before we close? Any other thing that you would like to ask? Sure. So boys and girls, we'll meet tomorrow hopefully, and then we'll wind up the last chapter, the last discussion. So take care. Good night. Thank you very much.